So before we finish with some applications here, I want to give a quick word on what are called non-square systems, where when we were working with that last example, we ended up having more variables, x, y, and z, than viable equations. There were only two that had any real meaning in either case. And in general, what we've been talking about to this point, what we'll focus most of our work on in this chapter are what are called square matrices, where a matrix is square if it has the same number of equations and variables. And it is non-square otherwise. So if you have more equations and variables, which we didn't see there, but we may see elsewhere, that would be another example of something being non-square. The terms you might see for this in other texts in future classes. By the way, this subject here is something with matrices in general, not this specifically, is stuff you'll work with in a class called linear algebra, if you ever get there. But there you might think of them in terms of being under and over determined, but that's a little bit of specificity we won't talk about very much in this class. Anyway, just a quick word here on the determination between a matrix being square and it not being square, which we'll see more of later.